So what we've done so far is we've talked about how to do integrals, what they represent, and then the next week or two is on how to use integrals to do various things. So one of the applications that we're doing is finding volumes. Now you need a little more generality than we have for this class, and it's actually in Math 2.0, Calculus 3, that you do the general version of volumes. But we can do volumes of some very regular things using the tools we have already. So, for example, things you already know, without integration, if I have a rectangular thing that is, say, width, height, no, height is usually up, width, length, and height, what's the volume of this? Length times width and height. Okay? Suppose I make it a little different looking. Suppose it's a cylinder. And this radius is r, and this height is still h. What's the volume of that? So what is the same, what is in common with these two things? They both have a height. Okay, that's good. There's a relationship between this pi r squared h, and if I take a saw and cut the top off, and look at that, or if I take the saw and cut the top off, and look at the area of that, this area is length times width, and this area is pi r squared. And it's no accident that the volume of this object is just length times width times however tall it is, and the volume of this object is h times the area of the cross section. In fact, that's generally true. If you can calculate the area of a cross section of something, then you know its volume. If you know the area of all the little slices, then you know the volume. And of course, I wrote this on one I can't raise. Good. I'm going to leave that, and I guess I'll go over here. So suppose we have something slightly more complicated. Suppose we have a pyramid like this. Let's make it square, so it's 3 by 3, and its height is, I don't know, looks like about 5. How can we figure out the volume of this? Yeah. This has 4. Now, I'm not asking about the surface area. I'm asking about the volume. Now, how could we figure it out? Yeah. So the area of the base is 9, and the height is 5. Do you think it's 45? No, because if it were 45, that would be the area of, if it looked like this. And that would be the volume of something like this, where this is 5 and this is 3 by 3. Right? This would have volume 45. So, trying to generalize this notion, don't tell me what the answer is, just tell me how we might figure it out. Generalizing this idea. Area of the base 3 times height? Why would it be that? Why would it be that?
Because as you go vertically, you're losing the area on each.
Okay, so let me, maybe you're right. Suppose instead of looking like that, it had, oh, that one I don't have to show you. That is a terrible illusion. Let's try it again. I want to make it sort of have a parabolic slice. Base here, something like that. So now I want to make it look like a parabola in the bit. So it's pointy. And you would stab yourself. This would hurt if you stab it. Ow. Again, this is 3 by 3. So I claim that the same idea here works here. What is the idea here that works here? Yeah. Well, it's not times the height. Yeah. So the idea to think of here is we take, so an integral is a way of adding up lots of little things. So if we integrate the area of a cross section the height from the height goes from, well, 0 to the top. I guess these are both 5 tall. This should be the volume. So in this case, that's exactly what we did. The area of the cross section is always pi r squared. The height goes from 0 to, I don't know, 2. So this volume is the integral from 0 to 2 of pi r squared dh, which is h pi r squared from 0 to, I don't know why I picked 2. I didn't know if it's 2. Whatever it is, big fish. Which is h pi r squared minus 0. So this gives us what we had before. Just integrating this thing from the bottom to the top. Here, the same. I'm going to integrate length times width, dh, and that gives me h times length times width. It's the same. I'm adding up these little slices. Here, it's a little more complicated. The slices are not always the same size. If I slice this thing, down low, so here, my slice is big. Up here, my slice is small. And then here, my slice is a point. The idea is the same. The size of the slice depends on how high up I cut it. So the size of the slice here is some function of the height. And if I figure out what that, and the same thing's true here. Here my slice is big, here my slice is small, here my slice is tiny. Again, the size of the slice depends on where I cut it. Unlike these guys, where the size of the slice does not depend on where I cut it. So, now maybe we can look at this a little more like the way that we set up an integral. We have some object here. I don't care what it looks like. I have some object here, and I want to calculate its volume. So I think of in order to calculate its volume, I cut it up into a bunch of chunks. So it's like a snake. It's a big wiggly thing. It was a candle, and it was hot, and it sort of melted. So I cut it up into a bunch of little cylinders, in this case, and I add up all of their little volumes. So I don't know, sometimes people, you may have seen where you make things, well actually, how many of you have been to or heard about the rapid prototyping lab they have over in engineering? It's a 3D printer. People know about 3D printers? So what a 3D printer does is, so it's a big machine, or a little machine if you buy a cheapy one, that what it does is when it wants to make an object, so there's also something called a MakerBot. Have you heard of MakerBots? No, it's a 3D printer. It's an object that you give it instructions to make a thing that you can hold in your hand. And what it does is it lays down a layer of stuff. It prints a little layer of stuff because it squirts out plastic or nylon, or the fancy one that they have over there has a powder that they zap with a laser and the powder melts. And then on top of it, it makes another layer of stuff. And it builds this thing up layer by layer. And in the end, you have an object that you can hold. You have to go pay to make it? So if you're an engineer and you take this class, then you can make stuff. Like right now, go over there and say, make me a thing, then they will charge you a fair amount of money to make you a thing. But if you have the thing, you can go over there, what's the guy's name? It's over in heavy engineering. You can say, hey, I heard about this rapid prototyping thing, it's way cool, tell me. And maybe they'll show you. It's cool. But yeah, it's expensive because like the big one that they have that zaps the powder with lasers, it takes about 10 hours to print, a whole print run of a volume about this big. And things are expensive, and so they would charge you a lot of money to make something. Well, not a lot. I think it's like, I don't know. But anyway, it does it by laying down layers of stuff. Well, we're doing this backwards. We're computing the volume by slicing this up, and then computing volumes of little things that add up to the big thing. Well, this is exactly what we did when we computed areas by integrals. Right? When we computed areas by integrals, we have some region, we slice it up, compute the volumes of the little rectangles, and add them. So the integral of f of x dx is the limit as the width goes to 0 of the sum of the rectangles. The same thing here. The volume here is the limit as the height, the little dh, goes to 0. So the volume is the limit as the height, the delta height, goes to 0 of the area of the cross section times the height. Well, this is an integral. Right, so this is exactly the same thing that we've been doing all along. So now let's do one of these specifically. So here I have this pyramid, and I want to figure out the area of the cross-section as a function of the height. So what do I need to know the area of the cross-section of the pyramid? I know the area of the base is 9. Suppose I want to know the area at height 3 or 4. What's the area at the height 4 of this pyramid? I mean of the cross-section. Right, so I'm going to take this pyramid, I'm going to cut the top off 4 inches from the bottom, and I'm going to look, I have a thing, when I cut the top off 4 inches from the bottom, that looks like this. What's the area of that? How can I figure it out? Tell me a number. You don't know. I can figure out this number. How do I figure it out?
Whoa.
Whoa. Yeah. Zero to 5 of. Well, I have to know what to integrate. Maybe you don't understand my question. I have to know what to integrate. So, what does the area of this cross-section depend on? Okay, forget about height for a minute. Suppose I cut this thing, and I look at it. It's a square. What do I need to know? Well, it's a square. The side. I need to know the side length. Okay, the side length depends on how high up I am. Right? The side length at the bottom is 3. The side length at the top is 0. What's the side length halfway up? Probably 1.5. What's the side length 4/5 of the way up? Probably 4/5 of 3. How can we be sure? So I don't know. So the side length depends on the height. Right? If I look at the bottom, I know that S of 0 is 3. And if I look at the top, I know that S of 5 is 0. What does this function S look like? Yeah. Why would it be that? Yes. So, this thing is a straight line. This is a linear function. So, we need a line. So this function S, if I put in the height, and I want to get the side length, when I put in 0, the answer is 3. When I put in, at height 0, S is 3. When at height 5, S is 0. This is a straight line because the sides are straight. So, what is the equation of the line that goes through 0, 3 and 5, 0? It is, so here, S minus, so the slope is negative 3/5, 5/3. Right? 5/3. So it's negative 5/3. 3/5? Yeah, 3/5. One of those. Yeah, it's like no. Yeah, it's like So when h is 5, you get s equals 0. When h is 0, you get s equals 3. Okay. So that's our function, right? That's the equation of that. So now the volume is what? An integral from something dh. What's the lower limit? Are people following this? I'm seeing a lot of blank looks. Anybody have a question? You're just writing. It goes from 0, right? The height starts at 0. What does it go to? 5. And what do I integrate? This? That's the integral I want? The whole thing squared, because the area is squared. So that's the volume, which I guess we could mush it around. So this is 9/25 integral 0 to 5 h minus 5 squared, which is 9/25. Why can't I do this? H minus 5 cubed over 3, evaluated from 0 to 5. So that's 125 over times 9 over 25 times 3, which is what? Why can't I do this? 9 over 3 is 3, and that's 5. 15? That seems right. Which is what the guy said before, because he knew the volume of a pyramid was 1/3 the volume of the thing. That's 1/3 of 45, so it's right. Okay, so this one was relatively easy, even though you seem to be confused by it, but okay. So now let's move on to the next one, which is the same thing. So I want to do the one that I erased. So now instead of having my pyramid be a straight-sided pyramid, I want the sides of the pyramid, I want it to look like this. I want the cross-section, the vertical cross-section to look like this, where this is the parabola. Let's do, so, why can't I think of this parabola? That's terrible. So, instead of 3, let's put this at 4. So this is, why can't I do this? X minus 4 squared. Does that work? No, 4 minus x squared. That's this one. This one is 4 plus x squared, and so on. Okay? So this is my cross section, and the base is still a square. So at the bottom it's 8 by 8. How tall should I make it? 8? No. It's whenever this hits 0. So how do I figure this one out? When the height, so the height function is 0, it's 8 by 8. Sorry? When x is 0, how tall is it? 16, right. When x is 0, we get 16. So this height is 16. Is it clear the thing I'm computing the volume of? It was this guy that I drew here before, except it's not 3 by 3, it's 8 by 8 now. So, what do? What I need to figure out is side length at a given height. If I tell you h, what is the side length at a given height? Okay? So, the thing that I need to know is, if I tell you at a certain height, 10, how wide is this cut? How can I figure that out? Yeah. Write x in terms of h. It's a good idea. So if I write x in terms of h, so I have, why can't I do this? Square root of h equals 4 minus x. So x is 4 minus square root of h. That's this side. And here our height is positive, so that's fine. And then this side, I can do the same thing, and I get square root of h is 4 plus x. So x is, square root of h is 4 plus x. So x is 4 minus square root of h. Something from. Oh, negative x's. It's twice that. So this guy is x is that one negative. So the width at h is twice 4 minus square root h. Right? So if I tell you that the height is 10, then the width of this thing is 2 times 4 minus square root of 10. If I tell you that something is wrong here, oh yeah, the height is 16, and the width is 2 times 4 minus square root of 16, 4 minus square root of 16 is 0, so 2 times 0 is 0, so that's good. Okay, so now I know the width, so what's the area of the cross section? No, I don't want to integrate yet. So what does the cross section look like? Yeah? Yes. The cross section in this case is a square. Its width is 2 times 4 minus square root of h. And its height is 2 times 4 minus the square root of h. So its area is this square. Now we can figure out the volume Someone want to tell me what it is? Yeah. Good. So what's that? Because 2 squared is 4. You prefer. It makes you happier. You do that. The whole thing squared. So this is the integral from 0 to 16 of 4 times 4 minus root h squared dh, which is, I don't know, some crap. So here, you square this out, 16 minus 8 root h plus h dh, 4 times 16h h squared over 2 from 0 to 16, which is 4, I don't know what 16 squared is. H to the 3/2, that's 4 cubed, so that's 64. So plus 16 squared over 2, which is some stuff. So that's 3/2. I don't know what it is. So I should know what this is. So 16 times 64 is 16 squared, right? And this is 4 times 16. If you take that. No. This is 4 times 16. And I'm multiplying by 8, so I can pull one of those 4s and do 16 squared. So that's 2 times 16 squared. This is 4 times 16 over 3. And this is, I don't know, some stuff. It's 3/2 of 16 squared here minus, and then this is 4/3 of 16 squared. So 3/2 minus 4/3 is, I'm sorry, 6. So I'm going to multiply this by 3. 9 6 is minus 8, so it's 1/6. So it's 4/6 of 16 squared, whatever that is. 4/6 is 2/3. It's whatever that is. Sorry, with the arithmetic. Not my strong suit. Okay, so the idea here is, in order to find volumes, you integrate cross sections. Okay? So that's the whole point here, is that volume is the integral of the area of the cross section. So now let's move on to something else, which is the same but different. I already squared it. The area of the cross section, whatever it is. This happened to be a square or not a square. The cross section in both of these examples was a square, so I found the side length and squared it to get its cross section. If the slice was a triangle, then I would need to find the area of the triangle. If the slice was Mickey Mouse, I would need to find the area of Mickey Mouse. Just a picture. I can't draw Mickey Mouse. It's a cat. I can draw a cat. So if the cross section is a cat, we find the area of the cat. Yeah, the eyes are hollow. Cut the eyes out. Every time I see a cat, I count its eyes out. My cat doesn't like that. Okay, so the general thing is that the area, the volume is the area of the cross section. That's the thing to take away. You can figure out the volume, the cross section, you're done. Now, often these are done in terms of, say I have, let's do it this way. Say instead of having a pyramid thing, I have a bowl. And this bowl has a parabolic side. So this is a parabolic dish. Like this. You want to find you find a parabolic dish that's from somebody's satellite hookup, and you want to fill it with water and know how much water it holds. They probably wouldn't appreciate that, but okay. So we have a parabola here, and we rotate it. So let's just do the parabola y equals x squared, and we rotate it around the y-axis, and this gives us a bowl. Like this. Let's say the parabola just goes from 0 to 1. What's its volume? So, what is the cross section? Cross section is a circle. If I cut it anywhere here, I get a little disc, and it has a radius. What is the radius? Is it? So, I have to think about where I'm cutting it. What do I know when I cut it? Do I know the x value? Or do I know the y value? Well, you can know either one. And if I know x here, then I should know y. But what is the radius? So the radius is, so this is certainly, is pi, so r is not pi. R is x squared. That's fine, but I don't know x necessarily. So let's just say r is x squared for a minute. And so then what is the volume? Yes? Yes? When you said x squared, it wasn't wrong. It's just as useless. Well, it's not useless. But... So since I'm rotating around the y-axis, I'm going to want to integrate dy. So x squared, if I know y, I want to know, right, the radius. Sorry, the radius is not x. I'm just wrong. So I need to know the radius at height y. So that means that I look at this parabola and I tell you the y value. And I want to know this distance. That's right, square root. So since this is y equals x squared, that means x is square root y. And so this distance is square root y. And then I'm going to rotate it around and get a disk of radius square root y, which I now integrate. So the area is pi square root y squared, which is just pi times y. So that means that the volume is what input? From 0 to 1, pi, there's a pi there, pi y, well, dy. If you want to call it h, then you have to, then pi h dh. But, so this integral I can do, pi over 2 y squared, evaluated from 0 to 1, which is pi over 2. Okay. So this volume is pi over 2. Okay, so that's not too hard. Suppose we decide to get weird and rotate it the other way. So instead of making this bowl shape, I want to make a horn now. Okay, so I'm going to take this parabola and I'm going to rotate it around the x-axis. And I make a horn. Blow it from there, make a horn. So I'm going to rotate my parabola around the x-axis. To get something that looks like that. So what do I do now? I put it in terms of x. So now my cross section is a vertical circle. And again, this is still y equals x squared. If I cut it somewhere like here, at a given x value, then I need to figure out what's the height. Well, what's the height? X squared. So here, at a given x value, cross section has area, so it now looks like x squared is my radius. So the area is pi x squared squared. So now I want to integrate for this horn. I integrate what? Pi x to the fourth. dx, because my slices move from here to here, they move from 0 to 1. Okay, so that is pi x to the fifth over 5 from 0 to 1, which is pi over 5. Right, yeah. So here, the lower and upper, so I made, this parabola goes through 1, 1. Here, the lower and upper values are y equals 1. Here, it's x equals 1. So if instead of doing, let's just change this problem a little bit. So if instead of going to x equals 1, let's go to x equals 2. In that case, if I go to x equals 2, this volume goes to 4. And I get 8 pi. Right, because I have 16 pi over 2. And if I go here to 2, then this is x equals 2. So then I get 2 to the fifth, which is 32. Yeah.
So when on the rotation on the y-axis, so we put everything in terms of y, and the rotation on the x-axis in terms of y.
If you want. So next time I'll do it if I prefer to do this in terms of x instead of y. So what I want you to do is to think about what the cross section looks like and figure it out. So I can just tell you a formula, but if you won't understand the formula, you forget the formula, you screw it up. I want you to understand the cross section.